I will ask you to set up and solve the inequality. And at first that looks like it might be something complicated, but I want you to consider for a second that we have a race, okay? And let's say that we both start here, and we're going to race to this line down here. Now, if you run this way to the line, and I run this way to the line, I think you can see very simply that this direction is much quicker than the way you were going to go, which is this way. In other words, this right here is a bigger direction or a longer direction, and that's what we're going to use to solve this inequality right here. So let's look at our triangle and let's recognize that this line right here, x plus 3, is bigger than the 5. So in other words, the crocodile eats the bigger number, which is the x plus 3. And from there it's dead easy, you just solve it just like you would an equation. So that's just going to be x greater than 2. Now I'd like to discuss 3 theorems, and here's the first one. It's this picture right here. I want you to look at what we have here. We have a pair of intersecting lines, and the fact that we've marked these 2 angles means that those angles are congruent. And if you think about this, what is the measure of all of this? Well, the measure of all of that is 180 degrees. And if we're going to say that these 2 angles here and here are the same, well, doesn't that mean that we have 180 divided by 2, which means both those angles are 90 degrees? In other words, if this is line L and this is line M, then L must be perpendicular to M. The next theorem is called the perpendicular transversal theorem, and this one says that if we've got 2 parallel lines, which in this case we do, and one of these angles is 90 degrees, that must mean that this one is also going to be 90 degrees. And then finally, the converse of the perpendicular transversal theorem says that if we have 2 pairs of lines, L and M, cut by our transversal, and these 2 angles are 90 degrees, then that must mean that L must be parallel to M. So we can do this.